Force on a charge kept at the vertex of a square due to other vertices charges. So here it is shown that in it we have a square here, and in this square here we have a charge q q q q. Four charges are there kept at the vertices of a square of side A is the side. So we have to find a force on any charge. So what will you do for that? So for that we will name it. We will first name the vertices, such as this is point A, B, C and D. Now suppose we want to find force on charge B. So force on charge B due to charge A is in this direction. This is the force F1. What is the force F1? F1 force. So I am writing this side. F1 force is equals to K, magnitude is Q at A and Q at B divided by AB whole square. So what will be? This is K Q divided by A square. So this is K Q square upon A square. In the same manner, force on charge B due to charge C is in this direction. This is the force in this direction. So this is force F2. So what will be the force F2? Magnitude. So F2 magnitude is F2 is again equals to K Q at B Q at C divided by BC whole square. So this is equals to again K Q A square. So this is K Q square by A square. So what will be the force on charge B due to this charge at D? So this is the force going in this direction. This is the force. This is said to be F3 force. So F3 force. So what will be the magnitude of F3 force? For this we have to find here BD. So what will be BD? BD is equals to A root 2. So this is BD. BD is equals to A root 2, or you can write it root 2A. That's better. Now what will be the force F3? F3 force magnitude is K Q at D Q at B divided by DB square. So this is equals to K Q upon root 2A square. So this is equals to K Q square divided by 2A square. These are the respective magnitude of forces. Now we are seeing that F1, here is F1 and here is F2. These two force produces a resultant force due to parallelogram effect. So let us make a parallelogram here. This is a parallelogram and this is a resultant force. This force is said to be F1 2. So we have to calculate force 1 2. Before calculating force 1 2, we need the angle between 1 and 2. So this is the angle between 1 and 2, which is 90 degree. So what will be the force? Let's slide a little upward and see it that F now, what is F12 is equals to F1 square plus F2 square plus 2 F1 F2 cos 90 degree under root. So we know that the value of F1 is K Q square upon A square. F2 is also K Q square upon A square. 2 K, here we have a square, whole square. So K q square a square into k q square a square, and cos 90 is equals to 0. So this is under root here. So cos 0 is cos 90 is 0. So this circle term become 0. So this will become 0. So what we will get? We will get this is k q square upon a square whole square plus k q square upon a square whole square under root. These two terms are same, so they add up and we get a result of root 2 k q square upon a square. So this is force F12 magnitude. Now let's see on the diagram again that force 1 2, this force 1 2 and the force F3 both are along the same directions. So they add up to give a total magnitude. So we will write total force magnitude is force F net is equals to F3 plus F12. So what is F3? F3 is, let's see here, what is F3? F3 is KQ square upon A square and divided by 2 on denominator side. So we will write KQ square upon 2A square. And what is F12? The value of F12 is here. This is root 2 KQ square upon A square. So we write it again, root 2 KQ square upon A square. In this both term, we have some common term. Take out the common terms. So it is KQ square upon A square. So under bracket, we have 1 by 2 plus root 2. This is F net. This is Newton. This is the resultant force which you get. So the resultant force, what is the value of resultant force? Read it. This is F net equals to KQ square A square under bracket 1 by 2 plus root 2 Newton.